This video is about predicting products. So usually we're going to be giving you problems where it's a single or double replacement reaction, and you're going to assume that the reaction that it is going to happen, and that all you're doing is just deciding who's going to be partners with who in the end. So for example, here's lithium plus zinc sulfate. We're going to make the assumption that lithium can go ahead and swoop in and steal sulfate, and that zinc is going to be alone. So what's going to happen is that this metal is going to compete with this metal, kick it out of the relationship, and now zinc is all alone. And then you're going to be able to know that a single replacement reaction, when you start with someone single and a partnership, it's going to switch so that one person is single, and then there's another partnership. So it's going to end up being lithium with that sulfate. But before you can just say that compound, you have to make sure that you're balancing charges. So you should know that lithium has a 1 plus charge, sulfate has a 2 minus charge. You're going to bring that 2 down there, and then you're going to bring the 1 down, which really means you can just erase that one. And it's going to become Li2SO4. Then the last step that you need to do for predicting products is just go ahead and make sure that everybody's balanced. So I'm going to start with zinc. I have 1 zinc on the left, 1 zinc on the right. They're fine. I can move on. I have 1 lithium on the left. I have 2 lithiums on the right. I'm going to go ahead and put a big 2 next to lithium. So now my lithiums are happy, my zincs are happy, and are my sulfates happy? SO4, I have 1 SO4 on the left and 1 SO4 on the right, which means that it is happy. When you're doing a double replacement reaction, let's say you have something like NaCl plus MgF2, and they want to know who are the product going to be in this double replacement reaction. All you need to look at is the 2 metals. What they're going to end up doing is just swapping spots. The metals are usually the guys that are in the front of the compound. So sodium's going to start with chlorine, but now sodium is going to end with fluorine. Once again, we know that sodium has a 1 plus charge, fluorine has a 1 minus charge. When you crisscross those, it really just becomes Na1F1, so we can just look at it like that. Plus, and then we have magnesium with chlorine, right? Because they switch spots, they switch their partner. Now magnesium has a 2 plus charge, chlorine has a 1 minus charge, so when you crisscross, this ends up having a 2 down there in the corner by chlorine, and there's technically a 1 here by magnesium. Now all that we have to do is go ahead and make sure that this is a balanced equation. So I'm going to start with sodium. Sodium's happy, sodium's happy. I can move on. Magnesium, another metal, is happy. Magnesium is happy. I can move on. Chlorine, I have 1 on the left, I have 2 on the right. That's not happy. I need to put a big 2 there to make it even. Now my chlorines are happy because I have 2 chlorines on both sides, but look, I have 2 sodiums now on this left side and only 1 sodium over here. So I'm going to go ahead and put a big 2 right there to make my sodiums happy. Now I have 2 sodiums here, 2 sodiums here. Finally, I'm going to look at my fluorines. I have 2 fluorines on this side, and I have 2 fluorines on this side, which means that this is my balanced equation. So the trick to predicting products is, do you know who switches spots? Usually the metals are going to switch spots with each other, and those are usually the first guys in the compound. And then all you have to do is just make sure that you're crossing charges so that you can actually make a truly balanced ionic compound, and then you balance as you always do. Oops.